In this video, we're going to go over section 5.1 from our textbook, which is a little introduction to rational functions. So we'll start with this definition here. A function f of this form here, where p of x and q of x are both polynomials, such that q of x is not equal to 0, this will be a rational function. And here are two examples of rational functions, as we can see. Now this guy here, this f of x is equal to 1 over x, is called the reciprocal function, and this guy is actually known as the simplest rational function. And so, here are some facts about this guy. Our domain is going to be all real numbers except for 0. X cannot be equal to 0, because if we were to divide by 0, this guy would be undefined. Similarly, the range is going to be all real numbers except for 0, because f of x will never output a 0. The only way for this to be equal to 0 is if our numerator were equal to 0, but we know that will never happen since we just have a 1 in our numerator. We also see that this function decreases on the open intervals here. It's going to be discontinuous at x is equal to 1, because like we said, x is equal to 0, because like we said, this will make this undefined. We'll also see that the y-axis is a vertical asymptote and the x-axis is a horizontal asymptote. It is also an odd function, and its graph is symmetric with respect to the origin. And so that's what we see in this graph here. This is our vertical asymptote, and this is our horizontal asymptote. And as you can see, the graph is not crossing either asymptote, here or here. So what we're going to do here is use this knowledge here of our reciprocal function, as well as what we know about graph translations, to help us to graph rational functions. So we're going to look at an example here. We want to graph this function here, this rational function, y is equal to 2 over x plus 1. So the first thing that we can do is rewrite this guy. So we'll have y is equal to 2 times 1 over x plus 1. And when doing so, we can clearly see that this here is going to be a translation of our reciprocal function. Our reciprocal function, 1 over x. So we can clearly see that this tells us we're going to shift the graph 1 unit to the left and then vertically stretch it by a factor of 2. Okay, so going back to our reciprocal function here, this is our parent function, this is what our graph looks like. So if we're going to shift this 1 unit to the left, this means our vertical asymptote is going to be right here at x is equal to negative 1. So we'll have a vertical asymptote just like this here. And then we also know that we have a horizontal asymptote like this here. And since we're not shifting our graph up or down, that will remain there. All right. So this tells us that our graph is going to behave in somewhat of this manner here, and this manner here in this region, just based off of what we know about our reciprocal function here. But let's write down some information about this guy. We know that our domain is going to be all real numbers except for x is equal to negative 1, right? Because if x is equal to negative 1 here, this will be 1 over 0, and we can't divide by 0. That'll make this guy undefined. So we know our domain is going to be all real numbers except for negative 1. We also know, due to this horizontal asymptote here, that our graph will never touch our x-axis, which means our output values will never be equal to 0. So this tells us that our range is going to be negative infinity up to 0, and then 0 to infinity. So all of our output values are going to be anything but 0. And then lastly, since we know that the graph is going to behave in this manner, it looks like at some point it's going to cross this y-axis here. So what we can do is try to find the y-intercept. And we know that we can do that by setting x is equal to 0 into our function. So we'll have 2 over 0 plus 1, which is equal to 2. So this tells us we're going to have a y-intercept at 0, 2. So that'll be right about that point there. So now we're good to go ahead and graph our function. We know to the right of this vertical asymptote, our function is going to look like this and intersect our y-axis at that point. And then to the left of our vertical asymptote, our function is going to behave like this. All right. And again, we just figured that out by using what we know about our parent function, this 1 over x here. All right, let's look at another example. We want to graph this rational function here. So what we're going to do in this case, so that we can rewrite this function in an easier way, so we can tell what our graph translations are, is we're going to use synthetic division. So first we're going to rewrite this guy here as x minus negative 1, right? Because we learned for synthetic division, if we want to divide these guys here, we're dividing by a binomial of this form. So, looking at the coefficients of this guy here, we have 1 and 2, and we're dividing negative 1 here. We know we're going to bring this guy down here, and since our k value is negative here, we're going to be adding these guys. So it'll be 1 times negative 1, so we'll get negative 1 here, and we'll do 2 plus negative 1, which is 2 minus 1, which is just 1. Alright, so this tells us that our quotient value is this guy, and then our remainder is this guy here. So we can conclude that x plus 2 over x plus 1 is going to be our quotient, which is 1, plus our remainder over our divisor, and our remainder was 1, and that'll be over x plus 1 here. So now it becomes clear exactly what our translations are of our parent function. This tells us that our parent function, which remember is 1 over x, is going to be shifted again 1 unit to the left. And then this here tells us that it's going to be shifted 1 unit up. All right. So based off of this, we know we're going to have a horizontal asymptote, again at minus 1, since we're shifting 1 unit to the left. And we're also shifting 1 unit up. So our original horizontal asymptote that was on the x-axis here is going to be shifted 1 unit up, right about here. All right. We also know that the domain of this guy is going to be negative infinity up to negative 1, and then negative 1 up to infinity. So just like as we saw in the last example, this is going to be all real numbers except for x is equal to negative 1, because having a negative 1 here would make this guy undefined. All right. Similarly, our range is going to be all real numbers except for 1. And we can see this with our horizontal asymptote here. We know our graph is never going to intersect this point, so our output value will never be equal to 1 here. We can also see that by looking at our function here. We know that 1 over x plus 1 will never be equal to 0, right? The only way for this to be equal to 0 is if we have a 0 in the numerator. So this tells us that this guy will never be equal to 1, since this will never go to 0. So our output will never give us 1 plus 0, therefore our output will never give us 1 here. All right. And based off of our behavior of our reciprocal function here, we know our graph is going to look something like this and something like this over here. So this indicates that our graph is going to intersect the y-axis and intersect the x-axis at these points, or somewhere along these points. So what we'll do is try to find exactly what those points are. So if you want to find the x-intercept, we'll just set this guy equal to 0. Doing so, we'll get that x is equal to negative 2, and therefore our x-intercept is up there. And similarly, if we want to find our y-intercept, we'll set x is equal to 0, and we get 2. So our y-intercept is 0, 2. So plotting these guys, we have 0, -2, and or -2, 0, and 0, 2 here. Right? And then based off of our parent function, the reciprocal function, we know that our graph's going to look like this to the right of our vertical asymptote and like this to the left. So the next function we're going to look at is the reciprocal of the square function. So that's this here. And in this case, our domain is all real numbers except for 0 again. If we were to plug in 0 for our x value here, we would get that our function is undefined. And all of our output values are going to be positive. No matter what x value we plug in here, we're not going to get a negative number since we're squaring it, and a negative times a negative is equal to a positive number. Right, so here are some facts about the reciprocal of the square function here. And this is the graph for this guy. So we see that the function is going to increase on this open interval and decrease on this open interval here. We also see that it's discontinuous at x is equal to 0, so it's not defined at this point, so we're going to have a vertical asymptote at this point. Similarly, we're going to have a horizontal asymptote at this point here. Our output value will never be equal to 0. In order for this guy to be equal to 0, our numerator needs to be equal to 0, but that will never happen. So we'll never get an output value for 0, so we're going to have a horizontal asymptote at the x-axis as well. All right, so we'll look at an example of this. Here we want to graph this function here. So we have 1 over x minus 1 squared. And so this tells us, since we have minus 1 within our square function, we're going to be moving 1 unit to the right here. So this is our parent function, which is the reciprocal of the square function, just moved 1 unit to the right. Okay. And based off of this graph here, we know that this means our vertical asymptote is going to be right here at this point here. And then our horizontal asymptote is going to stay right here along the x-axis because we're not shifting this graph up or down. All right. We also know that the domain for this guy is going to be all real numbers except for positive 1. If we were to plug in 1 for x here, we would get 0, and again, we can't divide by 0. Similarly, our range is going to be 0 to infinity. None of our output values will ever be negative because we have this square function here. We also know that our graph is going to behave in this manner here. So this indicates that we're going to cross the y-axis at some point. So let's try to find what that point will be. So our y-intercept we'll find by setting x is equal to 0. So we'll get our y-intercept is 0, 1. So that'll be this point here. All right, so we'll plot this guy. We know to the right of our vertical asymptote, we're going to behave like this. And to the left, we're going to behave like this, never crossing the x-axis here. So our output values will never be 0 and never going to this side of our x-axis because none of our output values will be negative either.